James Webb Space Telescope Mindblowers. 1. The James Webb Space Telescope, JWST, is so sensitive it could detect the heat signature of a bumblebee on the moon. 2. JWST launched on the 25th of December, 2021, and now orbits the Sun at a gravitational sweet spot called L2, nearly 1 million miles from Earth. 3. JWST can see light that has traveled over 13.5 billion years, peering into the very beginnings of our universe. 4. NASA's JWST confirmed carbon dioxide in an exoplanet's atmosphere, a crucial clue for finding potentially habitable worlds. 5. Deploying JWST involved over 344 single points of failure. Everything had to work perfectly, no second chances. 6. Unlike Hubble, which mainly sees invisible and ultraviolet light, JWST observes the infrared universe, revealing newborn stars inside dusty clouds. 7. Webb's early images showed ancient, massive galaxies forming just 500 million years after the Big Bang, rewriting cosmic timelines. 8. The colorful JWST images are actually invisible infrared light, mapped into colors that we can see. 9. Building JWST took nearly 30 years, cost $10 billion, and involved more than 10,000 people from 14 countries. 10. JWST's first deep field image, SMACS 0723, revealed thousands of galaxies in a patch of sky smaller than a grain of sand held at arm's length. 11. JWST's mirror is coated in gold because gold is excellent at reflecting infrared light. 12. The sun shield on JWST is about the size of a tennis court and made of 5 layers as thin as a human hair. 13. JWST can detect water, vapor, methane, and carbon dioxide in exoplanet atmospheres, the building blocks of life. 14. Some galaxies captured by JWST are so redshifted they're invisible to every previous telescope, including Hubble. 15. The James Webb Space Telescope can study the atmospheres of rogue planets, planets that drift alone without orbiting a star. 16. JWST detected the most distant active supermassive black hole ever observed from a galaxy that existed just 570 million years after the Big Bang. 17. One of JWST's goals is to find the first light, the very first generation of stars ever formed in the universe. 18. The James Webb Telescope uses a technique called gravitational lensing, where massive galaxy clusters bend light and magnify distant galaxies behind them. 19. JWST captured images of cosmic cliffs, gigantic walls of gas and dust, where new stars are being born in the Carina Nebula. 20. Despite its vast distance from Earth, JWST can pinpoint objects with an accuracy equivalent to aiming at a human hair from 1 mile away. 21. JWST observed galaxies merging and interacting, providing snapshots of how galaxies evolve over billions of years. 22. Using Webb, NASA observed carbon-rich dust being formed around dying stars, revealing the raw materials for planets and life. 23. Webb detected atmospheric components in K2 to 18b, an exoplanet that might have a deep ocean and hydrogen-rich atmosphere. 24. The James Webb Telescope will continue operating until at least 2030, and possibly longer depending on fuel reserves. 25. JWST's mirrors had to survive vibrations, equivalent to a rocket launch, and temperatures as cold as negative 370 degrees Fahrenheit during testing. 26. JWST's infrared instruments can detect light stretched so much by the expanding universe that it's invisible to the human eye. 27. In the first few months after launch, JWST captured images so detailed that galaxies previously seen as blurry smudges appeared with stunning structure. 28. JWST has revealed galaxies with mature structures like spiral arms forming shockingly early in the universe's history. 29. NASA's team nicknamed JWST's deep images cosmic archaeology because they uncover fossils of ancient galaxies. 30. JWST's first year of science operation discovered hundreds of previously unknown galaxies in small patches of sky. 31. James Webb's early release science program allowed astronomers around the world to use its data almost immediately. 32. JWST is capable of spotting planets forming around young stars by detecting heat from swirling disks of gas and dust. 33. One of Webb's surprising findings: some early galaxies are much more massive than astronomers predicted. 34. Webb observed the Cartwheel Galaxy in never-before-seen detail, showing rings of star formation caused by a galactic collision. 35. In studying the exoplanet WASP-96b, JWST detected clear signatures of water vapor marking a major milestone. 36. JWST observed star systems that are still forming planets catching the process in action for the first time at infrared wavelengths. 37. Webb captured the clearest view ever of the dusty heart of the Phantom Galaxy, revealing how stars spiral into dense clusters. 38. Some galaxies JWST has imaged look surprisingly modern, even though they existed when the universe was just a few 100 million years old. 39. Webb's observations of ancient quasars are helping scientists understand the earliest supermassive black holes. 40. JWST is expected to help pinpoint where the first heavy elements like gold and platinum were formed. 41. Webb's ultra-precise spectroscopy can reveal the weather patterns on distant exoplanets, including possible storms and clouds. 42. The light captured by JWST today began its journey when the universe was only 3–4% of its current age. 43. Webb spotted a rare Einstein ring where light from a distant galaxy is bent into a circle by a closer galaxy's gravity. 44. The Carina Nebula's cosmic cliffs, captured by JWST, are part of a star-forming region 7,600 light-years away. 45. JWST observations show that even tiny galaxies in the early universe had already started complex structures. 46. JWST captured the first detailed view of distant galaxies, forming stars at rates 10 times higher than typical today. 47. Some of the earliest galaxies observed by JWST are unexpectedly compact, yet extremely massive. 48. Webb detected atmospheric chemicals around exoplanets so faint they had previously been invisible to other telescopes. 49. Webb observed the Cartwheel Galaxy's shock waves, revealing the aftermath of a massive galactic collision. 50. Webb is helping astronomers refine the cosmic timeline of when the first stars and galaxies turned on. 51. Some star clusters seen by JWST formed just 100 million years after the Big Bang, astonishingly early. 52. JWST revealed hidden jets of newborn stars piercing through dense molecular clouds. 53. Webb's early observations suggest that the earliest galaxies grew larger, much faster than expected. 54. JWST is starting to reveal how the first black holes might have formed possibly from giant collapsing gas clouds without first forming stars. 55. Webb's mid-infrared views show older, cooler stars inside galaxies, complementing Hubble's observations of younger, hotter stars. 56. JWST's observations have detected some of the coldest brown dwarfs ever found colder than the freezing point of water. 57. Webb spotted evidence of complex molecules like polycyclic aromatic hydrocarbons forming in early galaxies. 58. The James Webb Telescope revealed clumpy, irregular galaxy structures in the early universe, suggesting chaotic early growth. 59. JWST is helping measure how dust and metals accumulated in galaxies during the first billion years. 60. Webb observed faint, red galaxies whose light has been stretched to extreme wavelengths invisible to previous telescopes. 61. Webb can detect exoplanet atmospheres even during partial eclipses, providing more chances to study them. 62. Webb's infrared vision reveals newborn stars hidden deep inside massive dust clouds. 63. Some early JWST observations suggest that massive galaxies formed faster than models predicted breaking cosmic timelines. 64. Webb's observations of gravitational lensing allow astronomers to study multiple images of the same galaxy distorted around massive clusters. 65. JWST will play a crucial role in helping find the very first stars, known as Population 3 stars, made only of hydrogen and helium. James Webb versus Hubble. Comparison facts. 66. Hubble orbits just 340 miles above Earth. JWST is stationed almost 1 million miles away. 67. Hubble primarily captures visible and ultraviolet light, while JWST specializes in infrared. 68. JWST's mirror is 6.5 meters wide, over 2.5 times larger than Hubble's mirror. 69. While Hubble needed multiple servicing missions, JWST is too far for repair. It had to be perfect at launch. 70. Hubble has captured the iconic Pillars of Creation, but JWST revealed an even deeper and more detailed view of the same structures. 71. Hubble showed us the beauty of the visible universe. JWST shows us the invisible, ancient universe. 72. JWST sees 100 times fainter objects than Hubble could detect. 73. Hubble images are sharp thanks to optical light. JWST can pierce through cosmic dust that blocks optical telescopes. 74. Together, Hubble and JWST provide a full-spectrum view of the cosmos, from ultraviolet to infrared. 75. JWST's gold-coated mirrors reflect about 98% of infrared light, compared to Hubble's lower reflectivity. 76. Hubble images usually take a few hours to create. JWST exposures can sometimes take several days to reveal the faintest light. 77. Hubble's primary mirror is 2.4 meters across. JWST's is 6.5 meters, nearly triple the size. 78. Hubble was serviced 5 times by astronauts. JWST is completely unserviceable in space. 79. JWST operates at about -370°F, requiring extreme cooling systems to function properly. 80. Hubble sees stars in optical clarity. JWST sees the skeletons of galaxies, hidden behind dust. 81. JWST's infrared view allows it to peer through the dusty birthplaces of stars that Hubble cannot penetrate. 82. JWST's sunshield blocks heat equivalent to 1 million times what the telescope can tolerate. 83. Hubble's deepest image before JWST was the Hubble Ultra Deep Field. Now, JWST's similar fields reach even deeper. 84. Hubble observed stunning supernovae. JWST can study the remnants and how they seeded the universe with heavy elements. 85. Together, Hubble and JWST offer a full timeline, from the universe's first galaxies to its modern structures. 86. Hubble's main camera views in the ultraviolet to near infrared. JWST operates entirely in infrared. 87. JWST needed to be folded up like a giant origami piece to fit inside its launch vehicle. 88. Hubble can observe galaxies about 13 billion years old. JWST is pushing closer to 13.5 billion years. 89. JWST's instruments include a mid-infrared instrument, MIRI, unlike anything Hubble had. 90. Hubble's best-known images are often colorful composites. JWST produces richer color data because of its wide infrared range. 91. Hubble took 15 years to complete its ultra-deep field image. JWST can achieve similar depth in a fraction of the time. 92. Hubble was launched by the Space Shuttle. JWST launched aboard an Ariane 5 rocket. 93. JWST's shield had to survive a temperature difference of nearly 600 degrees Fahrenheit across its layers. 94. Hubble's fuzzier infrared images are now sharpened dramatically thanks to JWST's advanced technology. 95. Hubble works at about room temperature. JWST operates just a few degrees above absolute zero. 96. Hubble's early images were blurry due to a mirror flaw corrected later by a servicing mission. JWST had to be right the first time. 97. Hubble orbits Earth every 97 minutes. JWST orbits the Sun along with Earth. 98. JWST's field of view can capture more galaxies in a single snapshot compared to Hubble's earlier deep fields. 99. While Hubble's mirror is made of glass, JWST's mirror is made of ultra-lightweight beryllium. 100. Hubble needed a coronagraph attachment to block starlight. JWST has built-in coronagraphs to image exoplanets directly. 101. JWST's 5-layer sun shield keeps its instruments cold enough to detect faint infrared signals from billions of years ago. 102. Hubble captured detailed images of nearby nebulae. JWST captures the very first stages of star and planet formation. 103. JWST's NIR-SPEC instrument can observe up to 100 objects at once, a huge upgrade from previous telescopes. 104. Hubble gave us the Pillars of Creation image. JWST revealed their deeper, intricate structure hidden inside. 105. JWST is helping refine Hubble's measurements of the universe's expansion rate, with some surprising tensions emerging. 106. Hubble's deepest optical images took hundreds of hours of exposure time. JWST can achieve comparable depth faster using infrared. 107. Hubble sees star nurseries' outer clouds. JWST sees into the hidden, denser birth zones. 108. JWST's mirror segments are individually adjustable with microscopic precision, allowing Webb to maintain perfect focus. 109. Hubble's NICMOS camera could see some infrared. JWST's instruments are fully dedicated to infrared performance. 110. JWST's MIRI instrument is cooled by an additional cryocooler system, keeping it near absolute zero. 111. Hubble can't see certain chemical signatures, like carbon dioxide, in exoplanet atmospheres that JWST can. 112. JWST's mirrors were polished so smoothly that if they were scaled up to the size of the United States, the biggest bump would be about 1 inch high. 113. Hubble provided the first strong evidence of the expansion of the universe accelerating. JWST is helping investigate why. 114. The wavelengths observed by JWST allow it to see light emitted when the universe was still opaque with hot gases. 115. JWST's field of view, while larger than Hubble's NICMOS, is much smaller than Hubble's wide field camera, but ultra deep. 116. While Hubble specializes in high-resolution imaging, JWST excels at dissecting light to reveal chemical fingerprints. 117. Hubble operates best in visible and ultraviolet wavelengths, while JWST is optimized for infrared. 118. JWST's instruments can measure tiny shifts in a star's brightness caused by orbiting exoplanets, something Hubble cannot do as precisely. 119. Hubble needed multiple software updates to stay competitive. JWST was preloaded with more autonomous operating protocols. 120. JWST's diffraction spikes around bright stars are caused by the hexagonal segments of its mirror, a signature feature. 121. Hubble's successor was almost cancelled multiple times due to budget concerns. JWST nearly didn't happen. 122. JWST uses microshutter's tiny movable doors to observe multiple galaxies at once during spectroscopy. 123. Hubble weighs about 24,500 pounds. JWST, despite its size, weighs only about 14,300 pounds due to lightweight materials. 124. Hubble is expected to continue operations into the late 2020s, working alongside JWST until it can no longer be serviced. 125. JWST's NIRCam can observe extremely faint objects with exposures lasting up to 48 hours. 126. Hubble typically orbits Earth at about 17,000 miles per hour. JWST orbits the Sun at about 67,000 miles per hour. 127. Hubble's orbit brings it through the South Atlantic anomaly, occasionally exposing it to increased radiation. JWST avoids this by being beyond Earth's magnetosphere. 128. JWST uses tiny puffs of gas from its thrusters to maintain perfect alignment for observations. 129. JWST's sun shield is made from Kapton, a heat-resistant material that can survive extreme temperatures. 130. Hubble was launched inside the Space Shuttle's cargo bay. JWST had to be launched folded to fit into a rocket fairing. 131. JWST's segmented mirror design gives it a much larger light-collecting area compared to Hubble's single-piece mirror. 132. Hubble focuses on closer, well-formed galaxies. JWST looks further back to witness galaxy formation itself. 133. Hubble's maintenance missions help develop satellite servicing techniques, now being adapted for future missions like Gateway. 134. JWST can collect light from objects 10 to 100 times fainter than Hubble could detect. 135. Hubble provided the first accurate age estimate of the universe, around 13.8 billion years. JWST helps refine that timeline further. 136. Hubble's images of the pillars of creation show gas and dust illuminated by young stars. JWST shows the hidden star, forming cores inside. 137. JWST's detectors use mercury-cadmium telluride semiconductors optimized for infrared sensitivity. 138. Hubble needs periodic calibration using reference stars. JWST can self-calibrate much more efficiently. 139. Both Hubble and Webb are considered part of NASA's Great Observatories family telescopes that revolutionized astronomy. NASA space exploration firsts and records. 140. NASA's Apollo 11 mission made humanity's first landing on the Moon. On the 20th of July, 1969. 141. The Voyager 1 spacecraft, launched by NASA in 1977, is now the most distant human-made object, over 14 billion miles away. 142. NASA's Perseverance rover, currently on Mars, carries a mini-helicopter named Ingenuity, the first aircraft to fly on another planet. 143. NASA's Artemis program plans to land the first woman and the first person of color on the Moon by 2026. 144. The first U.S. satellite, Explorer 1, launched in 1958 and discovered the Van Allen radiation belts around Earth. 145. NASA's New Horizons was the first mission to explore Pluto up close, flying by in 2015 and sending back stunning images. 146. NASA's Juno spacecraft is orbiting Jupiter, studying its massive storms and revealing the planet's deep, swirling interior. 147. The Hubble Space Telescope has made over 1.5 million observations since its launch in 1990. 148. NASA's DART mission 2022 successfully crashed a spacecraft into an asteroid, humanity's first test of planetary defense. 149. In 2024, NASA plans to launch the Europa Clipper to explore Jupiter's moon, Europa believed to have a subsurface ocean. 150. NASA's Apollo 8 mission marked the first time humans orbited the moon and captured the iconic Earthrise photo. 151. NASA's Mars Pathfinder mission 1997 carried the first successful Mars rover Sojourner, revolutionizing planetary exploration. 152. NASA's twin Voyager spacecrafts have both entered interstellar space, passing beyond the influence of the sun's solar wind. 153. NASA's InSight lander recorded the first ever Marsquakes, confirming seismic activity on Mars. 154. In 1962, John Glenn became the first American to orbit Earth aboard Friendship 7. 155. NASA's Skylab was the first U.S. space station, operating from 1973 to 1979. 156. The James Webb launch was so precise that it saved enough fuel to extend its life well beyond the original 10-year estimate. 157. NASA's Helios 2 probe holds the record for the fastest spacecraft relative to the Sun, reaching speeds of over 150,000 miles per hour. 158. In 2004, NASA's Spirit rover found strong evidence that Mars once had liquid water. 159. The Apollo 17 mission, 1972, was the last time humans walked on the moon, but Artemis aims to change that soon. 160. NASA's Dragonfly mission will explore Titan's surface with a drone. The first time flying craft will explore another world's surface. 161. The Apollo 11 astronauts left a plaque on the moon that reads, "We came in peace for all mankind." 162. The Mars Perseverance rover's MOXIE instrument successfully produced oxygen from the Martian atmosphere. 163. The James Webb Space Telescope used an Ariane 5 rocket from French Guiana, a rare non-US launch for NASA. 164. NASA's Lucy mission will visit Jupiter's Trojan asteroids, remnants of the early solar system. 165. The twin Grail spacecraft mapped the moon's gravitational field in unprecedented detail. 166. NASA's Artemis program will test new nuclear power systems to provide sustainable energy on the moon. 167. NASA's New Horizons spacecraft remains operational beyond Pluto, exploring the Kuiper Belt. 168. The Voyager spacecraft will continue to operate until their power sources run out, expected around 2025-2030. 169. NASA's Commercial Lunar Payload Services, CLPS, program partners with private companies to send payloads to the moon. 170. NASA's Pathfinder mission demonstrated new, low-cost landing technologies that paved the way for future Mars rovers. 171. The Space Shuttle was the first spacecraft designed to be reused for multiple flights. 172. NASA's Artemis missions aim to land astronauts on the moon roughly 50 years after the last Apollo mission. 173. The Opportunity rover found spherical formations on Mars dubbed blueberries, evidence of past water activity. 174. NASA's Voyager spacecraft entered interstellar space faster than any human-made object. 175. The Hubble Space Telescope required astronauts on 5 servicing missions to replace and upgrade key instruments. 176. The Ingenuity helicopter on Mars completed the first powered flight on another planet in 2021. 177. NASA's Deep Space Network keeps track of more than 30 missions simultaneously across the solar system. 178. The Apollo 15 mission carried out the first deep drilling into the moon's surface, reaching about 10 feet deep. 179. The James Webb Telescope's first images were unveiled by NASA and President Joe Biden in a live global broadcast. 180. NASA's Artemis I Orion spacecraft traveled more than 270,000 miles from Earth, farther than any crew-rated vehicle before. 181. The Mars Science Laboratory Curiosity carried the first onboard chemical lab to analyze soil and rock samples. 182. NASA's Perseverance rover has collected over a dozen core samples from Martian rocks as of 2025. 183. The Apollo 11 lunar module Eagle left its descent stage permanently on the moon's surface. 184. NASA's Pioneer Venus multi-probe mission sent 4 atmospheric probes into Venus's dense clouds. 185. NASA's Parker Solar Probe is expected to make 24 progressively closer passes to the Sun by 2025. 186. NASA's Voyager spacecraft were launched using a rare planetary alignment that occurs only once every 176 years. 187. The Mariner 10 mission used Venus's gravity to slingshot itself toward Mercury, the first gravity assist maneuver. 188. NASA's DART mission proved that humanity can alter the path of an asteroid by direct impact. 189. NASA's Voyager 1 is now traveling through the interstellar medium, a region of space between stars filled with cosmic rays and interstellar gas. 190. The Mars Perseverance rover has a drill that collects core samples from rocks once submerged in ancient lakes. 191. NASA's Lunar Trailblazer mission will map water ice on the moon in preparation for future human landings. 192. The Artemis program aims to establish the first permanent habitat on the moon's surface. 193. NASA's Near-Shoemaker spacecraft successfully landed on the asteroid Eros, the first spacecraft to land on an asteroid. 194. NASA's Solar Orbiter, in partnership with ESA, is providing the closest ever views of the Sun's polar regions. 195. Ingenuity, the Mars helicopter, became the first aircraft to complete a successful night survival on Mars's harsh surface. 196. The Apollo 17 mission carried the only geologist astronaut, Harrison Schmitt, to the moon. 197. NASA's Capstone spacecraft tests new navigation methods critical for future Gateway Lunar Station operations. 198. The Dragonfly mission to Titan will be the first to explore an alien world entirely by rotorcraft. Earth and Solar System surprises. 199. Earth is the only known planet with liquid water on its surface, yet water exists in vast quantities as ice throughout the solar system. 200. NASA found a liquid water lake under the ice of Mars hidden beneath its south polar ice cap. 201. Venus spins so slowly that a day on Venus is longer than a year on Venus. 202. Jupiter's moon, Ganymede, is the largest moon in the solar system, even bigger than Mercury. 203. Saturn's moon Titan has lakes and rivers, not of water, but of liquid methane and ethane. 204. The largest volcano in the solar system is Olympus Mons on Mars, about 2.5 times the height of Mount Everest. 205. NASA's Parker Solar Probe became the first spacecraft to touch the Sun's outer atmosphere, the corona. 206. Uranus rotates on its side, tilted more than 90 degrees compared to other planets. 207. The Kuiper Belt beyond Neptune contains thousands of icy bodies, including Pluto, Eris, and Haumea. 208. NASA's OSIRIS-REx mission collected samples from asteroid Bennu and returned them to Earth in 2023. 209. Earth's magnetic field protects us from deadly cosmic radiation. Without it, life would likely not exist. 210. Mars lost most of its atmosphere because its magnetic field collapsed billions of years ago.